welcome to Rotec and welcome to our first coding and marking panel. I'm Richard Pether, and with me I have two of our design guys, Miguel Mari and Peter Lisher, or perhaps in order of seniority, Peter Lisher and Miguel Mari.
I'm just the older one.
The hair colour probably gives a clue to the ages. What we want to do in this format is have really a bit of an informal chat amongst ourselves that we hope you'll find interesting about some of the things going on in the business, some of the innovations, some of the things that we've been doing in recent times. And for our first one, we thought we'd start with 3D printing. 3D printing has become an integral part of our business, not just for prototyping, but is also now very much part of our production process. And that's really been driven through our design team, who now can design with the 3D printing method in mind. Peter, how long is it since we first had a 3D printer in the building?
We started about 3.5 to 4 years ago with a resin-based 3D printer, Formlabs. What we found was the on-costs with the Formlabs, where you have to print it with the resin, you have to clean it with IPA, which is a health and safety issue, and then cure it afterwards, was quite time-consuming. So shortly after that we bought an Ultimaker 3, which is a filament printer, and that sort of kind of embedded us a little bit. We had quite a long learning curve with it, just getting used to how you could design components, how you could actually orientate them on the base plate, and in fact how you can actually make them stick on the base plate. It's just one of these here, and I'll probably see a closer up later on. This is what happens when a product moves on the base plate. It starts to shift the layers over. Obviously this is what it should look like before it comes off, but that's what can happen. So we had quite a long learning curve. Then probably about 18 months ago we kind of invested heavily into two more printers. One was a Teartime, which was a bit of quite a novel idea at the time when we bought it. I think we got the first prototype unit that came out.
Yeah, I think you're right. Yeah.
And we actually worked with the Teartime engineers to improve the running of that. And we had several visits from their engineers who came over from China to talk to us. The advantage of the Teartime is that it has 12 plates which automatically load and unload, so you can set 12 jobs up, leave it for the weekend, come back and find your, hopefully you've got all your products printed, and something like that hasn't happened. We then carried on, and about 8 months ago we bought a Sigmax, which was a twin plate unit, so you could print the same component but on 2 plates, and that was just again a size. So something like this, which is an HMI moulding, this will be printed on the Sigmax, and we could actually print 2 of those side by side. So the actual production time is halved. Rather than, I think you probably get 2 components in about 25 hours, something like that. Maybe one of the disadvantages with 3D printing, but the other hand is you can set it and it will run lights out.
Yeah, yeah.
So, yeah.
That's probably one of the areas that we've learned most, I suppose, about the reliability and the lights out running, because obviously with a 25-hour job, you don't want it going wrong as soon as you've locked the factory up and gone home for the weekend. You want to know that it's going to run, and that when you come in on Monday morning it's complete. And by and large, I think that's really where we are now. The experience we've gained and the knowledge of how the printers run. I think we've got quite a program of servicing, haven't we? We you know, there's a weekly check sheet for each printer that we make sure it's running correctly. If it needs any cleaning, if it needs any adjustment, we're doing that to make sure that it really is a production-ready machine all the time. Miguel, you've got a couple of parts there. Sorry, that's I think a before and after, where we injection molding and now we 3D print.
Yeah, we're injection molding these parts, and what we notice is that these parts are not too complex. So we thought we'd try starting to 3D print them, which is what this is here, and you get the same structural rigidity and same look and everything, except just with such a higher turnover time. So I think something we learned as we got different printers was the time that each printer is good for, the time frame that you need if you want to print something out. So we have the Ultimaker, which is good for, if we're doing a prototype print or maybe a small production part. As we grew our range of 3D printers, we realized that parts like this, which are production parts that we need to make en masse, are actually very feasible since we can put lots on at once and just leave it to go for the week.
Yeah, I think that was one of the possibly misconceptions when we first looked at 3D printing. We were perhaps told that you want to keep them compact, you want to get as much printing done in a small area. You don't want to print too much in the Z dimension because that's adding time to it. But of course, as we've said with the long print jobs like 24 hours, well, what does it matter if it runs over the weekend and it produces the job, or it runs overnight? Then it doesn't matter if it takes a bit of time. And certainly on these blades, we've managed to make them stronger from a vacuum formed shell that had to have a reinforcing plate in the bottom of it and was still a little bit fragile. With the 3D printed version, we can start adding fillets and webs in as we want to try and give it more strength, and we're probably printing with a fundamentally stronger, more elastic material than we were when we were injection molding. So something like that, possibly you'd look at and say, well, that wouldn't be economical to 3D print. Actually, it is, and we get a better product as a result. So,
I think from the design point of view, one of the more interesting aspects is actually the change in design philosophy, which we're actually allowed to be maybe more creative. This is, we'll get a close-up later on, but this is a slide unit for one of our printer assemblies. To produce that in aluminium would be quite a complex machining job, but in 3D printing, we kind of print it in that direction. And again, as Richard says, you can print everything on there, and it requires a little bit of a clean up afterwards, but the actual end result is very cost effective, and probably no more than £1.50 for that, I think. Also looking at this sort of thing, this would be an adjustment system for one of our sort of labelling applications. And what we've got in here is this will alter the position of the web. And what we've got is actually we can 3D print the rack profile into the plastic moulding. So instead of in the old days, if I can call them the old days, we'd have to buy a rack in, machine it in, place it in there, obviously more machining, drilling and tapping, etc. But now it's just absolutely just moulded in or designed into the actual end component.
Yeah, in fact, that moving on to this component, which is the drive roller from the RF Lite.
Yeah.
That is a roller that's got a hex profile to the shaft because it runs on a hex shaft. Now that, again, pretty difficult to produce that, and certainly expensive if you're going to make it out of or start from solid. With a 3D printer, 3D printer doesn't care whether you print a round bore or you print a hexagonal one. So that's a very cost-effective way of producing what's actually quite a complex profile and a very key part of one of our machines. So
I suppose on that same way of thinking, it's additive manufacturing, so we're adding filament where we need to, whereas making something like this, for example, this would have to be, if you want to machine out of a massive block.
yeah,
All of the stuff on the inside is just waste material. So being able to print something like this where we only use the material that we need is also a lot less wasteful of material instead of buying in, a massive block of aluminium for that entire piece and then removing the entire middle bit of it.
I think that moves on, nicely to the point that some years ago, if you were making something like that, and say you were making it out of aluminium to start with, then as a British manufacturer, you might be looking at ways to reduce the cost, and a lot of people would look at offshoring that, going to a lower cost economy that could make those parts for less money. And this is really turning full circle, because now we're saying, well, no, we don't want to make it out of aluminium somewhere else. We'll 3D print it here. So we've got control. We've never really done that. We've always supported our local subcontractors on milling and turning and sheet metal, but of course many companies have. But you know, we're very conscious of the fact that now we've got total control over the production of the item, and we're 3D printing it for ourselves at a lower cost than if that was to be made from solid. So it's really reversing that cycle of bringing component manufacture back in-house, because we're running on 3D printers which are really driven by the design guys and the factory guys. But the factory guys are supervising the machines. They're not actually bent over a mill or a lathe having to produce them. Once the machine's up and running, for the most part, it keeps going and it produces exactly what we want.
I think one of the knock-on effects from that is that whereas before we'd be looking at bulk purchasing to get the price down, for example, the vacuum form guides, that we'd have to buy those in 100 off quantity, whereas now we can just print them to order, which means that we have to don't have to keep more stock than we actually need for the month's shipments. Again, we don't have to place bulk orders. It's obviously cash flow. So it has had quite a lot of ramifications, I think, in terms of how we run the business and
Yeah, that's true.
look at stock. I think let's sort of come back to maybe the engineering side of things. One of the things we've been learning over the time we've been using these is, I think as we said, we started off with the Ultimaker, and at the time we used filament and a PVA support structure. One of the things we found with that was that once the product had been printed, you had to soak the PVA in water to get rid of the support structure. That obviously made it a little bit more messy, so we've moved on from that, and now support structures are made from the PLA filament that we use. There are quite a few little sort of customisations you can make within the printers, if you might say that you can alter the support structure to give it the most cost-effective internal support, plus make it as strong as possible. We've learned quite a bit about inserts, brass inserts, how to mould various nuts into the system so you get the maximum amount of not just strength of material, but actually if you're trying to physically clamp something, we can do that now. I think one of the things we have learned is that things like this, which would be a roller for one of our sort of applications, very good for printing it, very round, dimensionally accurate, but absolutely no good running on a bearing surface, so we have to insert bearings into these. So that's the one thing we have found, is that in a dynamic situation, you still need to have bearings to make sure that everything rotates freely. I think we've had a couple of issues where maybe thrust washers have been made out of PLA, but they soon get destroyed, so you do need to use proper bearings and think about the dynamic situation if your component is in that kind of situation.
Yeah. And how many variants of filament do we have?
We tend to now just use PLA.
Yeah.
We have tried ABS and a couple of others, but I think the problem we found with ABS is quite brittle.
Yeah.
And if someone just happens to knock it or drop it, it can shatter quite easily. So we found PLAs to be the best, pretty much the most common solution or common filament that we use.
Although the factory is always constantly getting samples from different suppliers with different materials. I think recently we've tried another kind of PLA, just with different properties, and also carbon fiber and onyx mixed together.
Yeah.
So that looked nice, had a nice finish, and it was also quite strong. So it's interesting to see how eventually we might be able to make parts that are actually bracing structures out of 3D printed material as well, because it's just as strong.
Yeah, I think as the 3D printed technology grows and people are more getting used to things, we've still got metal printing, which is still, I think, a little bit in its infancy. I might be wrong there, but we have had a couple of components made out of metal filament or metal produced 3D, but they've not been quite as dimensionally accurate or as good as we would like. But I think technology is moving on. Manufacturers are obviously trying to keep at the forefront of the technology. So I think as they grow, we'll be looking at other 3D printing technologies as well, just to grow our own in-house capabilities.
Yeah.
You've still got 3D printer at home, haven't you?
I do, yeah. A couple months after I started working here and we started messing around with the Ultimaker, I realized that I wanted to do projects, but as our scale and amount of parts we needed printed were growing, I realized I had less and less time to squeeze a little print in between work jobs. So I got one at home, and they go for as little as £100, maybe 200. And I think it's really helped with understanding the software behind it,
I think you're right.
being able to apply that to parts here at work as well.
Yeah, I mean, we've even got a small sort of prototyping printer, haven't we? That if you want to try material or a smaller part, there's 6 printers in total. And the smallest one we can use for, say, a bit of prototyping, but that's almost a hobby size or home size type 3D printer. But there's absolutely no reason why you can't be using these at home, as Miguel finds, and we get a lot of benefit from his tinkering around at home. But he understands the principles, and the principles are the principles. But that's probably where the knowledge and where the understanding comes from. Just the time taken to try printing different things, always pushing the parameter, and then you end up being able to do the more complex things and do them in production. So then they become production parts that we know we can rely on.
Yeah. So I think this is again a bit of an example of what we're producing. Again, this will be produced on our larger plate system. It's actually the one of the sort of end panels from our RF Auto. Was originally purchased as outside by a local plastics machinist, and it would be just a flat plate which fitted inside the RF Auto panelling. And now we've changed over to this, which actually fits over the outside and gives you a nice clean edge around the panel. So again, it's just just looking at what we can do in-house as against and sort of purchased from other suppliers, really.
And if you've ever fitted a panel that needs a couple of spaces behind it, the thrill of threading a screw through a panel and a spacer in 2 locations and then fitting it to the machine. You can have retained spacers on screws, but here we have retained spacers on panel because we just print the spacers into the panel. So that goes on, 2 screws go in, and that's it, held onto the machine. So again, all of those things come into play to make life easier, gets the part count down, makes assembly easier, the sorts of things you can do.
And I know that recently we've been starting to try printing in different colors as well.
Yep.
So I'm sure we can put a picture up on the screen, but we recently printed out a panel for one of our more bespoke machines. We were able to get a black background with orange text on top of it.
Yeah, the Sigmax is a twin head, so for the most part we would use them split into 2, print in 2 parts simultaneously where the heads are just moving in tandem. But you can load one colour filament into one head and one colour into another, and then you can have a 2-colour print. So in this case we printed a black background plate, and then we printed the wording on the top in yellow, orange in orange.
Yeah. That's the other advantage of the 2-plate system, which is that you can have one component, but if you want to mirror it, the software does it automatically. So you actually can reduce drawing time, the development time, by just making one component and allowing the machine to do the mirroring.
Yeah, clever stuff.
So yeah, we're still learning.
Well, we're always learning. We're always learning.
Yeah.
Okay. Well, look, we hope you've enjoyed our bit of rambling around 3D printing and learned a little bit about what we do here and how we've managed to implement that into our machines, which we hope is something that brings benefit to our customers. It certainly brings a big benefit to us in our time to respond, both in time from designing something to having it ready to go, and also just in general production. Lead times on parts have come down a long way by the fact that we can 3D print them. So thank you very much for joining us, and we hope you'll join us on another one of these another day. Thank you very much.
Bye.
Bye.